All right, let's go ahead and jump into section 2.20. This is on inequalities. We have already talked in previous lessons that there are certain situations in the real world that are better modeled by equations, and there are different situations that are better modeled by inequalities. Usually, if there is a single or a select few answers or that are going to be solutions, then that would be an equation. And if there's a whole range of answers, then that's going to be an inequality. So what happened here was we were given two different situations. One would be modeled as an equation and one would be modeled as an inequality. And students were supposed to figure out which one was which. So the first one says Martha is buying pizzas from Little Caesars. She buys 2 bottles of soda at $4 a piece and then a certain number of $7.75 pizzas and spends a total of $54.50. How many pizzas did she buy? So we are going to be solving for a specific number of pizzas. It's not going to be like a range of the number of pizzas she could get. So that would be an equation. So you set up the equation as 8 plus 7.75p equals 54.50. Now in this one, I accidentally said $7.50 for the pizza. It was still supposed to be $7.75, just like the previous problem. But on here, it says that she can spend at most $54.50. Same situation, but just now she's not spending exactly $54.50. It's at most, which tells me there's going to be a range in the number of pizzas that she can get. So the situation that we have here on one side will be the 8 plus 7.75p, and on the other side will be 54.50. What I've found is that for students to get these right, the best thing they can do is not put the symbol on the inside yet, just write the left and right side, and then ask themselves afterwards. The left side represents how much I'm going to spend. Can that be less than 54.50? Can it be more than 54.50? And can it be equal to 54.50? And once you answer that question, it helps you figure out which way the symbol should go. Since they can spend at most 54.50, that's going to be less than or equal to. So you end up getting that inequality, and then we solved it. Remember, when we solve an inequality, it's just like solving an equation, except for you need to switch the sign if you ever multiply or divide by a negative. Now, there are going to be many different solutions that this has. So mathematicians, being efficient, decide that they are going to graph the solutions. So if we want to graph the solutions for p is less than or equal to 6, that means 6 is going to be the number that divides the solutions from non-solutions. So you put a dot at 6. It's going to be a closed dot because it is less than or equal to, meaning 6 is a solution. If it was just less than or greater than, it would be an open dot because that would not be a solution. And I know a lot of people just say if it's less than, shade to the left, if it's greater than, shade to the right. But I've seen kids get in trouble that way and not understand what they're doing. So the best way you can do this is to pick a point, test it. If it works, shade on that side. If it doesn't, shade on the other. So we tried 0. Is 0 less than or equal to 6? Since it is, we knew we were going to shade to the left. If that was not true, we would shade to the right. After that, the students had to look at situations and write inequalities. Once again, I highly recommend that you just write the left side and the right side first without the symbol, and then ask yourself what symbol makes sense. Like in this case, they say the trailer itself is 2,300 pounds and the boxes are 30 pounds apiece, and the trailer axle can hold at most 3,000 pounds. So the left-hand side represents all the weight, and all the weight, is it allowed to be greater than 3,000? No. Can it be less than 3,000? Yes. Can it be equal to 3,000? Yes. So that would be that situation. The next one says that you are having a delivery to your house from Walmart. It's $10 for the delivery fee, and it is 9% tax. You can spend at most $100. So we know the amount you're going to spend is delivery plus the cost of the item plus tax. Now on the right hand side there, delivery is 10, cost of the items is X, and tax is 0.09 times X. It is not 9 times X, it's not 0.9, it's 0.09 times X. If you wanted to, you could combine the X and the 0.09X and get 1.09X. So you have 10 plus 1.09X. You have 100 on the other side. Since it's at most, it can be less than 100, cannot be more than 100, and it can be equal to 100. So that is why it was less than or equal to. The next one was talking about a situation that actually happened to me. They had a deal going out on at Sprouts, and if you spent more than $50, you got 10% off of your bill. So I had only spent $16, and I decided that I just would stock up on something that I knew I was going to end up eating, which are these ham slices for $7.99 per ham slice. So the equation, well, it's not an equation, it's an inequality. But the left-hand side, how much I spend is the $16 that was already there plus the $7.99 times the number of ham slices. The right-hand side would be the 50. And then I started asking myself, can I spend more than 50? Yes. Can I spend less than 50? No. Can I spend exactly 50? No, because it says you have to spend over 50. So it's good to write the left and right side, and once you have that, then figure out which symbol you're going to use. On these ones right here, what they did was they just went over and solved all of the different inequalities, making sure to switch their sign if they multiplied or divided by a negative. Once they got to the point where the x was by itself, it made it very easy to graph. You would just know that the dot would be at that location, either open or closed, depending on if it was less than or greater than, or if it was less than or equal to, or greater than or equal to. And once you had that, you could test a point on the right or on the left. But whatever point you test, if that point makes the inequality true, you would shade on that side. If it did not make it true, you'd shade on the other side. So students went over and solved all of these inequalities, and once they had that, they figured out which graph matched. There's some easy things you can look for. The open and closed dot is probably the easiest. Anything that is less than or greater than has to be an open dot, cannot be a closed one. So that was that. On the bottom here, students had two more problems. On these ones, depending on how you did it, you would end up most likely having to switch your sign because you multiplied or divide by a negative. At that point, you would have to figure out if you had an open dot or a closed dot, and then test a point on the left or on the right. And if it is tested on the left and that point makes it true, then shade left. If that point does not, shade on the right. It's just whatever point you try. If it works, makes the inequality true, then shade that side. If it does not, shade the other side. Now on for the homework. On this one, it was talking about a person who had an inequality. They changed the inequality to an equation. Remember, this is not how we usually solve inequalities. This is just trying to get to a conceptual understanding. What do you end up getting? You end up getting the location that divides the solutions from the non-solutions. It says, how can Lynn determine whether x is greater than 1 or x is less than 1 is the solution to the inequality, because they found out that 1 was the dividing point where the solution started. And all they had to do was try any number either greater than or less than 1 to see if it works. And if it works, then it tells you which side would be the solutions, whether you would have x is greater than 1 or less than 1. The next one is talking about a phone contract. You can either spend 10 cents per text or you can spend 2 cents per text, but then you have to pay $12 per month to be able to get that deal. I decided to do pennies rather than dollars. You can see the two different inequalities there. One represents if you did pennies, one represents if you did dollars. I did the pennies one though. And when I solved this, I found out that if you do less than 400 text messages, it's better just to spend money 10 cents per text. If you are going to do over 400, then it's better to do the deal where you pay $12 up front. The next one, when you're solving this, it says, what was the error that was made? The error that was made was they forgot to switch the sign when they divided by a negative. On number 4, they were supposed to solve these. You solve it just like a normal equation, but if you ever multiply or divide by a negative, switch your sign. Remember, we talked about the reason to do that is if you had a true inequality, like 10 is greater than 2, and you multiply both sides by a negative, it makes a true inequality false. The only way you could keep it true would be to switch the sign. So on the first one, the reason I gave A was just to make sure you guys remembered to multiply by the reciprocal after adding 1 to both sides. The reason why I gave B was because I wanted to make sure that you guys knew to distribute the -5, not just a 5, and then make sure that you knew how to solve a inequality where you had to distribute, combine, and then solve. You did have to switch your sign on this one because you divided by a -1. And the next one, depending on how you do this, whether you subtract 2x or subtract 7x, you may or may not have to switch your sign. But in the end, you end up getting x is less than 4. On this one, it says without actually solving for x, what are values of x that would make this true? Well, negative 10 would be negative 2 times negative 10, which is positive 20. And 20 is not greater than 20, but any number slightly smaller than negative 10. So any number less than negative 10 would work. But when you solve it, if you forgot to switch your sign, then that would be saying any number bigger than negative 10 would work. So that didn't make any sense. That shows why you would have to switch your sign when you are multiplying or dividing by a negative. On numbers 6, A and B, you just had to figure out where you were going to put your dot, whether it was going to be open or closed, depending on if it was had the or equals to part. I intentionally did B because a lot of people would see that as less than and think that you shaded to the left, but it's actually saying X is the bigger one because the mouth is eating the X, so you should be shading towards the right. Better way to do that is test a point. So if we tested 8, let's say, is 5 less than or equal to 8? Yes, so you should shade in the direction of 8. On these ones right here, you just have several situations. I intentionally gave you some problems that mimicked problems that you guys struggled with in the last unit. One of them had to do with percents. A lot of people thought 9.18% was 9.18 or 0.918, but it's actually 0.0918. You may have had the inequality that you see there, or you may have had 32 plus x plus 0.0918x is less than or equal to 100. As I told you, the best thing to do with these is write the left and right side and then figure out which symbol makes sense by asking, can this be bigger than? Can it be less than? Can it be equal to? The next one says that you have to spend over $69. So you already spent 27 bucks and you're going to go over and buy a bunch of soups because you know you're going to use those at some point. So it's 2.75 times x. X is the number of soup cans. I should have defined that. The left-hand side represents how much I spend, and that has to be greater than 69 bucks for me to be able to get the free shipping. The last one, it's $5.50 per movie. X is the number of movies, so it's 5.5x on the left. On the right, you spend $20 on the monthly fee, and then it's 1.5 times x, $1.5 times the number of movies. Now it is asking, when would it be cheaper to go with the membership? So that is, since the right-hand side is the membership one, you want to make sure the mouth is opening to the other one, and you're saying that the right-hand side is less. All right, hopefully that made sense. Don't forget to switch your sign when you multiply or divide by a negative, and when you're writing your inequalities, it's good to write both sides, then figure out what the symbol should look like. Thanks for watching.